will be presented by Konstantin Nazarov. It is about platform as something, as service, and will be about Docker, Consul, and Python. Let's say hello to him.
Всем привет.
Good day, everyone. I'm sorry for the Apple logo here. I have Emacs there, not Apple, don't worry. And I will speak today about how using some tools to make your own PaaS, Platform as a Service. Before we start, you might ask, who is this guy talking here and teaching us about that? I work at Tarantool company, and I once had this necessity to start instances of databases all at once, and I made a tool. First prototype was ready in 2 weeks' time approximately. Very fast. I will try to do here a live demo of that process if I manage. You can see much better. This is a command line interface from which it started that works nearly as Docker, and it has a run command that can create an instance of, say, database, for example. And then it returns identifier, and that identifier would allow you to see which instances were launched, launch one more. And as you see, they are listed here, and they are launched in replication. I provide IP addresses statically to them, and I will clean now very fast them from the system. Remove them. That is what was done in first iteration in 2 weeks. It's a working system, nevertheless. And I would now describe how you could do the same on your own. There's nothing magic about that. That is based on use of standard Linux tools. It's a standard approach. That is how the system looks graphically. It consists of a Docker to launch a console and some Python elements. Why I needed to do this? In the market, there are solutions that allow similar launch of containers and managing of containers. The problem is that those existing solutions are very inefficient with stateful services. And I didn't want to invest much upfront in order to teach Kubernetes of how to correctly work with that. And I would put it this way. If you have your own product that you develop, that you need to host and scale, I would consider seriously writing your own orchestrator for that. When not to do that? First of all, if you have a monolith service, and this service you cannot switch off optionally, in such case, orchestrator would not work nicely. Orchestrator is designed to make use of switching off some services and relocating that to a different machine. So the stateful services, they shouldn't be idle. What should PaaS be able to do? First of all, launch your services, and second, abstract those services from operational system. Let us see how that can be built. We will start building from small blocks, bricks, starting with command line interface, the simplest one, and we'll finish with a solution which is a higher level and which will require more time. You will be able to export that knowledge and this approach to the system that you deal with. And you can stop at any stage of this development or redo it all over again using different tools. Which bricks I would use for this construction? Python. First of all, Python I would use because it has a lot bindings and extensions. When I looked, it would not be exaggeration to say that Python has bindings for practically all large systems. And where there are none, somebody is already writing those. And I use that as a glue of sorts. Docker is the second thing I would use. I'm not a fan of Docker, not much. I think that Docker so far is not perfect yet. I would speak about that later, also in detail. But it is convenient, nevertheless, because it has a remote API, which is a convenient thing. By default, this API is accessible from local host, and it can use a socket, a Linux socket. HTTP request can be launched to that. That means you could have this port outside and connect to that any other elements, and I use Docker as a packaging format. People complain that Docker is used to make install software. In Linux is not quite appreciated. In Docker you can do that.
So what's the beauty of Docker is its simplicity and those conventions which are embedded into it and a good documentation. Downsides are those bugs. I encountered Docker bugs repeatedly in many versions. The network was very weak and inferior. Like daemon Docker was stuck, container is operating, daemon Docker is stuck, it does not respond. So it's rather difficult not to damage the container and reboot the Docker at the same time. And Docker had plentiful of bugs. Docker community for bugs is the following. Docker community is saying you should upgrade. We issued new version. Everything's upgraded there, but it's modeled up what's broken there. What are alternatives to Docker as the building block? However bizarre it might seem, I suggest we should use for that German. German is the Python library for work distribution. It enables to install agents on several servers and launch on those servers the arbitrary apps via unified API. That will not provide you that convenience as with Docker, but if you need isolation, you can do it. What is the benefit of German approach? The benefit is that you're not confined to Docker itself if you have to launch not on Linux but on alternative platforms. German will be operating either way, and in most likelihood it will work more robustly if due to some reasons Docker is not good for you due to its network model, let's say. And a Nomad is a German idea which is more sophisticated. It's brought to the pinnacle of perfection. Nomad manages the launched work assignments on the cluster. Consul Well, who knows what Consul is all about? Raise your hands. A lot of people. Consul is the thing which combines distributed kernel storage and service registrator. It's based on several nodes and big Windows nodes and peers, raft consistency peers. QL storage is based on this distributed model. In QL storage, you can store the configuration of our services. Apart from that, the console gives us the service registry. It's the way of telling the system, I have a service, it lives on this or that host, and it has got different ways of testing its integrity. How does it do it? Consul has got an agent installed on each machine. Consul itself questions the services as how they feel. First way is a shell command. Second way is HTTP command in Docker container and many other things. Consul is a very good building block. I use this building block for state storage as a bonus here as well. Consul has another advantage, very convenient Python IP. Everything's written, you don't have to reinvent the wheel. You just install several peers of Consul, connect them to each other. You tell the Consul, get together a cluster, and then you have very robust storage. Which alternatives to Consul are around? TDCD could be used as QLs. In most likelihood, DTCT does not support service registration. And I think that service registration is needed, but if someone already has DTCT as a distributed QL storage, you can use it. And is Zookeeper. Zookeeper is more of Java world. It's also distributed to QL storage, but not quite QL storage, but rather a framework for construction. First approach. Let's start from making an interface, which I mentioned. It's command line interface. Why do we start from command line? Because it's possible to implement it within 2 weeks or even briefer than that, provided you have got professional Python software engineers. They'll cope with it in no time. What do we need from this command line interface? First of all, for it to create instances, to consider them, to modify, upgrade whenever it's necessary, just the conventional CRUD interface. How should we use it? I suggest such a scheme for that, as was demonstrated at the outset in the video trailer. Docker has got a very good and smooth command line, and I mimicked that command line directly. I just borrowed it. All those commands, run, PaaS, RAM, inspect, all of them are embedded into it. Run command should create instance and return identifier. Upgrade command should upgrade from one version to another. If the versions are applied for QRM command should delete. Everything is crystal clear. But what's less clear is how to get to Docker per se. It has got HTTP, which could be used outside from within, but there is some problem related to that. How to expose this HTTP API, because Docker doesn't have any identification out of the box. It does not have basic authorization, which would be very convenient in the beginning, at least. That is why at this stage you'll have to deal with that. Machines with HTTP Docker outside will be accessible from your intra-network. All you'll have to protect them with the help of Tailor and client to authorization, but it's fraught with many problems. For example, you'll have to generate certificates, and to create your certificate authority, which is not so very pleasant altogether. We start from the following. You're exposing Docker and all the hosts. You register all those hosts in a console, so the information appears. It's enough for you to have one point of access into console. You should, your mind should connect to console and ask him, where is the Docker nodes? Where are the Docker nodes? And you get the list, the response with a list of servers and ports. Then you can connect to those hosts individually and create a container there. Very simple. When the container is created, after that you'll have to register it in console, saying that container is living on this machine. And apart from having the way of creating container, you have a conceiver view system. I did not show it here. I didn't show you the screenshot of console overview systems. But later on, if you're interested, I can show you how to select physical nodes. It's very challenging to do it right. You have got a very simple script. You started from that. Your script should make a decision where to launch a container. Question, how to do it. The most straightforward way of doing that is to make a random decision. That's what I made from the very start. I didn't write any sophisticated chat over. Then I made the random launch it a randomly selected server. Next solution which crossed my mind was to record how much resources a specific container needs. When you launch a container, I had a parameter what amount of operative memory it should use. You write down the parameters and use pessimistic algorithm of allocation. If the container is allocated, then it should use this memory, and you should not give up this memory. You allocate to the hosts based on the number of theoretically used memory. A problem related with that is that maximum density is not reached, but it's a very good approximation. As Consul has, got health checks, it knows how to collect digital numerical values, not just commands. You can use Consul as the probe in order to collect the information about the current borrowed resources. The most sophisticated and challenging things is not about allocation or creation of the containers, but create versions. For example, database is a big headache. We had to implement the logic which creates databases into copies, and master replication is tuned between them. When we have to upgrade this database, first we just launch one of those two containers. The load balancer automatically calculates that and shifts the traffic onto another one. And after the upgrade, the container is lifted up back. Then replication is done, and same is done with the second container, which worked well for this straightforward container-based approach. If you have a stateful service, it will be good to do that. If you don't have great requirements for ARP time as the first step, you don't have to think about seamless rebooting, but just to stop the server for 1 second, to use another container next to it, to use the data from the first container. It's possible to do that and see whether it will be rebooted again. Otherwise, you should use the older container. It's good in many situations. As a result, we get wonderful system which will implement your simple tasks the way you want it. Maybe it wouldn't be able to do different sophisticated things, shifts, jumps, whatever, but it's good for your specific use case. That's good altogether, because for many software products and for many commands, the ability to start movement towards automation really rapidly is way more important rather than selecting the coolest solution. Let's figure out how it's possible to improve this solution. First way of dealing that is about those health checks. You may use give up the status on HTTP. That's the simplest approach for microservices. You make HTTP a point, and all the languages enable you to use embedded HTTP server, and you use the status, and there are bindings between different pieces of your system. And there is something else to it. That's network. There are big problems related to networks when we deal with Docker, and I had a solution in a very smart way. I'll tell you how. Why is a network problem for the Docker? First of all, there are lots of different ways of tuning up the network between the containers. They don't work normally. There are some overlay networks encapsulating traffic in each package. Wix LAN, and there is MacWLAN, and there is OpenOS or switch, which is operating, but you should integrate it. You should sort this out. What would be ideal? Let's say there are two containers launched on different machines, and they should be able to be reciprocative, not just they could be a project, but they could communicate to each other. In our case, it was needed for switching the replication of databases between one container and the other. As I said, we're using master-master replication just to make the system robust. So you may start them, and they will be operating. What could be a problem with MacWLAN? I will not speak about all those problems. Because I've got the whole information on YouTube. What's the problem with MacWLAN? It may use Consul in order to have the dynamic topology of the routes. No, it's VXLAN between the overlay networks. The speaker corrects itself. He uses himself. It's possible to use Consul to store the topology of routes if Consul is having downtime or it's stuck and switches masters both ways repeatedly, and there is a failure of the console. It's very simple, seldom, but it could happen. So you can figure out why the traffic is stuck. Suddenly containers which were communicating to each other in a good way, after moving, for example, moving over, one container cannot communicate to the other container, although some other adjacent containers can. This is about the overlay network topology, which is dynamic. This container shows the route in the kernel. There is one suggestion, rather funny, to use Linux bridges by use of magic. It's possible to make Docker not to create the internal bridge on the machine, but to adapt external interface to your machine, and the inner bridge Docker, they will be spanned by one bridge. The gimmick is that you're just creating Docker 0 network yourself before the Docker is launched again, and make it a bridge. After Docker is launched again, it sees the existing network. It will not set it. Docker should be in compliance with the way you set up the network, so there should be some IP address, so it will be the same. What's the problem with such an approach? And where major costs are sitting? Operators management. By default, Docker allocates API addresses on its own account, the allocation of API addresses. How can we possibly bypass this allocation by Docker of API addresses? Most simple way, you are creating not overlapping range addresses on each physical server, and you tell the Docker allocate or use for allocation of API addresses this part. That will work. That's most simple way. More sophisticated way of doing things is to allocate API addresses on your own account. That's what I have been doing. I have got 2 hosts. On each one, containers are sitting. They are added up to the shared bridge. In the console, I store the tag with API addresses. As soon as I launch out of the script a new container, I add up the kernel inscription that I allocate such and such API to such and such service. After which SQL is consistent and transactional. After that, no one will be able to occupy this API. So it became my DHCP. I implemented that, but it works differently. This allocation is done from the side of the orchestrator. The beauty of it is that you don't have to launch your own daemons. You may launch Consul Docker and use this command line utility to implement entire logic. Actually, that's all you have to do at the first stage. Second stage, let's improve the accessibility of this thing. Let's launch it as a service. Why? Because of security reasons. As I mentioned, Docker, which is sticking outside, is a bad idea. So everyone who has got the access to API access, control the machine fully, can launch processes differently and so on, is the launch of preferred containers. And then it's possible to give access to your colleagues, for example. So at the end of the day, it would be enough to have command line written at the previous step and to split it into 2 parts: implementation as a service, getting commands and service to that. That way you'll provide people with command line and they will be using one access point that will protect you from deadlocks and from competitive access to your doc, like 2 admins who are going to launch something at one and the same time. They will not encounter the error in your system, because of which the servers might not be created, which would have been potentially possible at the previous stage. How do I do it? There is a Flask. A Flask is a very simple web-to-work for Python.
And documentation is basic documentation of how to use it is 1 page only. And then you can start to use it, the service. One more important thing is GEvent. GEvent, you not necessarily use it this step, but I suggest you can involve that already. GEvent is an implementation of corporate multitasking in Python. It makes out of Python not Erlang, but something more convenient. You don't program, you just have a possibility to program concurrency too, but you don't deal with threads. Instead of threads, you use GEvents, and your logic of orchestration, which looks like state machine, is a sequence of commands. For prototype, this is very important. If earlier in the previous example and first step, you using these means to manage, the system could be sequential, but when you start to scale up the system, you need to do it so that the system could run a few parallel processes, and GEvent will help you to do that. Why these instruments are necessary? I said already, it's easier to write code for that. What you should remember this step is that you have to separate states. you shouldn't allow state to seep into orchestrator. Orchestrator should not store anything. Orchestrator should not store anything. If you can do that, if you can avoid that, you can use Consul as a database. There are transactions currently, key values, and also transactions can be stored there, can be done a lot through that without a dedicated database edition. And that's it. Other items are minor here. Stateless is important here. Third step, let us improve it even further, writing administrative interface. Why we need an administrative interface? From my practice, when I was writing that, I had to relaunch services many times. They were down many times. Orchestrator was malfunctioning. Something else was happening. And as it turned out, for myself, although I am quite comfortable with Consul, I remember all the shortcuts, bastions, and so on. Not major ones, I think. Not all. There are too many. What can be that interface looking like? That is what I suggest. Very simple. Should return the same information that you have as a console in each instance, and providing an overview service as well, looking up a list of servers, condition of servers, and what is the current condition of the Docker. The status. This screen is more informationally saturated than what you have in a simple console. I have a color coding. Upper line is yellow before the service is live, until the service is up. A console makes verifications, and this is shown in red. As soon as it is live, that is changed to yellow color. I generate a usual HTML. How I do that? You have a simple Flask templates. Ginger 2 is a language with templates. Ansible also uses that. And Bootstrap. Because nobody sees that besides me, Bootstrap is also quite appropriate. You can do HTML and it will look very nice as Bootstrap, and not as much as a basic HTML without the styles attached. Bootstrap is CSS framework. You don't need to know what it is. CSS CC at work, and then you can do the HTML and it will look nice. What you have to have at this step, overview is most important. Overview of the whole system, with a clear to understand condition or status, and a possibility to do some operations. As I figured out from my experience, the most useful operation is delete, although it might seem strange. Why is delete important? Because when you write external surrounding for orchestrator, next level of abstraction, more convenient interface, for example, sooner or later you have a situation where you lost some information, some identifier of container or a service identifier, and this step you will have to clean that up somehow. Before you have automatic cleanup, you can do that through this interface. Let's proceed. One more item is important, is delayed tasks. Earlier, you could also do that through command line, adding that command line to cron, but that would create changes in behavior of the system, would be more unpredictable. If you have one, you don't have a single point of entry, services. To add such services in a situation, could create raids inside that you don't know about, and that would spoil function. A cron job would be started, and then you have something to do manually about that. What this you might need for backups, for example, or to collect certain data for analytics. Backups, although many people like to do backups in automatic way, so the service will do backup automatically, your service knows that there is certain storage and it stores all files there regularly, and that is ideal. You don't need to write additional to that. But if you want to be to do it as part of your service that you write, that you should write then the launcher for that backup. GEvent and Docker. Docker, as I said, exec API. It has very nice features. Through HTTPI, you can launch any command and container. If you know container host, you can connect that host 88 port through that, and then you ask the API to launch a command of backup, for example, appsync or some similar command, or archive something. And then Consul, you can add for that a verification that would show either red or green color when backup is happening. And here you will make use of GEvent. You can write sequential code and nothing will be blocked. You can just do remote call of that. Exec API would also allow you to get output commands. While the commands are processed through API, you will get console output, which is convenient because you can immediately show that either in shell or in UI, and to understand the problem immediately if you see that. How it is done? Most simple way. This is a thread for knitting. Probably not quite good picture, but this is a metaphorical image to working fiber. Working fiber is started through event spawn. You start a function through Docker and API. That function goes to container, executes a command there, and that function can directly pull output. It's very simple. What is important is to know that it's possible to do. That's convenient call, and it will save you much time in automation. Because such hacks, they are recognized after a while, and they get known, and you can combine different systems in this way. And also would be good to collect some metrics about that. Metrics is a problematic issue because soft exports metrics very unwillingly. You have to add additional monitoring program that would really make sure that soft would disclose what is happening, provide some metrics about processes. If soft has the capacity to output metrics, that is excellent, but that's not always the case. And the problem with metrics is the system of collection of metrics is rather complex. For example, Hadoop, for example, you may deploy for that. Those who worked with Hadoop, they know what I mean. It's not that difficult, but it's a pain in the ass. You would get a lot of pain additional just to deploy the system and to monitor. Or graphite. Also not very pleasant. That is additional. Graphite is not convenient. Let's wait for Q&A part, questions and answers. This is not convenient. That can be attributed to all systems of collection of metrics. You need to keep up additional service for that. If system is simple, and if you do that through a simple system, and you should start as soon as possible, then you should simplify metric collection. How to make this simpler? Why I explained already? How to do it simpler? You can save metrics, store them in orchestrator at the first stage. Short set of metrics that can be stored in memory directly. that would allow you to collect key metrics once a second, for example. Even usual Python dictionary is sufficient to keep that short metric information over acceptable period of time. At the beginning, especially, there not be that multiple, and later at the next step, this is my proposal actually. You can start with this. You can start with a simple retaining of that in the memory, and second, when you proceed further, when you understand that memory is not sufficient or your service is down for the first time because there is some killer, you have to think about the separate storage of metric data, and Prometheus is what I suggest. Why Prometheus? Is because Prometheus can store this information and to show also to a certain extent. Not convenient. Dashboard is required additional, but that would allow you to install additional servers and through API to connect direct through orchestrator and collect the metrics and transfer that. How to export metrics into Prometheus? One of the ways is to make your services to send their metrics directly on their own. If you do it, that is preferably. You could push that from each service to the Prometheus. And you can do it differently. You can push it through orchestrator. Orchestrator will collect them. Metrics data is monitoring agent of sorts because it knows where what is stored in. It can collect that and send it to Prometheus. That is a simple way to develop further technology. If you were collecting metrics in memory, you can just reflow that to Prometheus in this way. That is how it would look. Also, you can make Prometheus to contact Consul. This information from orchestrators is shown here. This Prometheus is Consul, and information on your containers in the first step. In Consul, you provided information to other services. That is convenient. And Prometheus has integration with Consul. That is what I did. For example, when metrics were multiple to store, I added Prometheus and set it, telling that this is hosts for you and monitor that. That is a workable solution. I set the HTTP port for that operation, and using certain protocol, I provide to Prometheus what it wants to see, quantile, histograms, and some other data as metrics. You can start with usual counters. It is also a breadth of sorts, also useful. A simple way to integrate Prometheus into the system, as I said, is at the central orchestrator to integrate that. If you want more convenience, you can embed it. Prometheus has bindings to all popular languages. You can embed it in your language, in your application. A convenient collection of metrics at the language level. You'll have objects as a Python, that is a simple Python object that in Condeck you could use, or a record and a column of histogram, anything. And then Prometheus would open up the port on its own, if you allow that, of course. And Prometheus would collect this data once every 10 seconds. So this is all system. And now let us remind us what we talked about. First of all, Docker Python and Python Consul, two more important construction blocks. You can do a lot with those two if you have sufficient imagination. You can configure orchestrator. You could add additional control functions, automation, custom assembly. You can do with the help of that. The slide will also be available at the end, and the references to additional information. Then you can do Flask serving, admin UI, GEvent for delayed tasks, GEvent delayed tasks and asynchronous code, and Prometheus for monitoring. Prometheus is not necessary if you don't want to include that. This is a diagram once again, which I showed in the beginning. And here, what I added from myself to the system is this element. This element is UI for the user interface, because on the left is admin shown, which works with the control panel that I showed to you before. And this control panel provides a lot of opportunities. These opportunities the users do not use most of the time. And I created one more application on Python, which provides additional, more convenient interface. We can deploy that inside our system at the admin computer. And providing users one button, start the service. After that, several upgrades were created where you could simply move over a file to a browser and launch it in the system. What is convenient? And this step, of course, required a bit more time for this beautification, for additional functionality. That is now operational in the internet. There is a public beta system, and this is a multi-source system. The orchestrator that we have written, it is in Python, and it is available at the hub. Thank you for your attention. Now, questions and answers. I have a question also. I had some eggs. Who of you remember this?
Bridge, правильно.
So, who remembers on which slide there was that snail among those Easter eggs? Clockwork snail. Anyway, questions. When I hear about master, well, I want you to expand on what you mean, because there are some conditions to be complied with, otherwise master will not be possible. Well, master is not possible, but if you give it a try, you might think about something. We have got an asynchronous master. We're not fearful of losing data because we are using those services which are in master application. We use them as cache. We use cache emulations in Tarantool. There is some module above it which is the service like a memo cache. It has got disk persistence and replication of one node to another, but actually it's cache at the end of the day. For more serious situations, let's say it's Postgres, it's better for you to set up master-slave, then it'll make your life more fun because you'll have to use failover. How can you do failover with Postgres? There are lots of publications about it. You can do it for upgrade, like manageable failover, but that's going to be rather challenging. Lots of logic. If there is a machine installed, you'll have to do it. For state machines, you might approach me about it. I know how to manage very sophisticated state in Python with those machines. I know little gimmicks to tip you about. More questions? Tell us more about state machines, especially about Python parallelism. In Python, when it comes to parallelism, it's rather challenging, but when you're writing orchestrator, you don't give a damn about it because you don't have a CPU-bound task. All the task is IO-bound just to start several entities which are waiting in parallel and make some steps. You don't need real threads. Moreover, threads and such a decision will entail lots of rather peculiar consequences. Don't use threads whereby you may avoid using them. For that, GEvent is made. GEvent will enable you to program as though you have threads, but without threads. For every operation as I/O, like dispatching a package, you'll be able to reconnect. There is a shadow over at blocking operations. It just reswitches those screensets. This entity actually can have different tasks. As to state machines, unfortunately, I don't remember the name of that Python package, but there is a real cool Python package, so you'll be able to program your machines, state machines, in a very easy object-oriented, on the very easy, simple object-oriented basis and bottom line. You can do it out of the integrative environment, which is called Jupyter now. There is the visualization of those state machines. You can check out the diagram of shifts. You program state machine, see the diagram of transitions, test it dynamically. You may even connect to this dynamic environment your own orchestrator and make it run the scenario on the real hardware or on some set of hosts. That's about it. That's how it works. You said that you have got a production Docker network. Bridges are, it's just a question. Yes, it works. You mentioned that sometimes the system stucks. I don't use overlay network. Once again, I don't use overlay network because, frankly speaking, I'm sort of fearful of overlay network. I don't know how to debug it in a good way. So I would recommend you not to use overlay networks whenever it's possible. If it's utterly impossible and you don't have any other alternative, then maybe I would open switch, which is more streamlined. There are more ways to resolve the problem. When I tried to debug with Docker overlay, when I was testing it, I was getting onto the articles about open switch. There is the guy called Jerome Peterson, correct me if I'm wrong. He is engaged in marketing. He is like the gospel preacher in Docker, but he's the guy who is going to rewrite everything. He has got the Pipework set of utilities. I can show you. Pipework is those utilities, is a set of scripts, so Docker network could be managed differently. Docker network is about network namespaces at the level of containerization, so it can adopt network adapters there. Previously, it could do Macwlan. By the way, Macwlan is a wonderful solution. I would recommend to first to use Pidgin, then Macwlan, and only after that you should think about overlay. More questions? To recap on the issue about the fact that we are using this over switch and it creates us problems. I didn't use it because there were challenges related to Docker, and I found the information how to resolve it in OpenReswitch, and I exported that solution onto the Docker. I tried to figure out this system. I have a question. You used GEvent when you looked at the system. You didn't look at Twist and Wane. Well, as to Twisted, I were aware of Twisted since long way back, and I was thinking along the following lines. You should get an instrument which would be very straightforward. Your task is to have an objective to make it in 2 iterations, 2 weeks, Within 2 weeks, within 2 iterations, you'll write down the basic system. For your basic system, it's important to be very simple. GEvent is in line with this criterion of simplicity. You might take GEvent, write down the consecutive code, twist it, and its analogs are more akin to state machines. They are not using they are not using certain like callbacks, like in JavaScript. Everything is about function, and here they are concealed in these very sophisticated object models. So I didn't contemplate twisted it. There are any alternatives to GEvent if you are not going to use GEvent. Look at, say, when in Python 3.6, 3.5, they support asynchronous mode there, but I don't like Python with its asynchronous support. I like GEvent because I like its flavor. It's palatable for me. Anything else? Could you make a comparison of your orchestration to Kubernetes or OpenShift? My orchestration, for example, supports my product. As to Kubernetes, it does not support it. That's a very important element. That's why I am telling you about it. Bottom line issue here, to my way of thinking, in many situations when you have got stateful Kubernetes and even Mesos and Mesosphere, they'll provide you with a very simple opportunity to set state with service. They have got transparent scaling. Kubernetes, 200 human years, man years, like we say, it's more than 1 million of line codes, string codes. Kubernetes drops, we don't know what to do with it. I never had big problems with Kubernetes, but theoretically, if it happens, like Kubernetes started recreating some containers, it's difficult to understand why. It's way simpler to understand it with your own orchestrator. There are some points beginning from which Kubernetes becomes better than the solution, like building block. You can use Kubernetes as the orchestrator and to have your own orchestrator of high level above. It's advantageous when you've got extra people. Now I am developing the entire software product myself, front-end, back-end architecture, HTML monitoring, administration, all by myself. Best factor is one in such a situation. Yes, I am on my own, but I'm a startup. I'm entitled to act that way. More questions? Let's put our hands together for Konstantin.